problem just now, so we continue the question. The next thing we want to do is to use binary search to achieve the same answer. So it's quite a mess here. We change to so instead of storing the values into the hash map, I will store it into the array list now. So we have the value stored in our array now. Next thing is we want to search. So this is the value. But we need to perform a filtering. I think we don't need to perform a filtering, but we need to have the values marked as true if we found that. So the max is expected value, which is some minus the value. So I set my flag for this value to true, which we can no longer find the use back the same value. So our minimum is 0, our maximum is option count, then we can do a search. Minimum plus maximum divided by 2, and if target, we can ignore we can actually don't have to need to use a fact. We can do the comparison directly. If target is expected value, so this is the options list. And if the mid is the same, we don't care. We can proceed to do other things. Then we can break. We found the solution. Goes to the value. Second value, our expected value at the counter. If it is the same, then we need to consider whether the neighboring values are of the equivalent values or not. In this case, 40 here, so we mark, we already chosen this, then the next, then we should choose the neighboring. First, an important part that I have left out is to sort the options because the question didn't state that the values are sorted. So we need to sort it first. If options list value um, so this is the mid value. We also need to check the down and mid less than option count minus 1. So we will compare it. Okay. So it should be plus 1. So in this case, we will cater for the same numbers but in different position. So since we are sorted then, so the next number should be side by side with the origin number that we have chosen. So the next thing, more than expected value, max equals to min minus 1, else min equals to min plus 1. So I think that should be it for the solution. Six and 4, and for this case 40-40. So index of bound we need to break this value as well. Found the solution. So okay, 40-40 it works. So for this solution, I am looping through the values. For this case, I'm looping the first value to be 2 because I've sorted it, and I will find the expected value will be 8. Then we found the expected value by using binary search. And it is a working solution. Then next we proceed to 4. Then we also found 4 and 6 is a solution, and 8 and 6 we also found 6 and 4 is a solution. And at this stage you might think, okay, I can actually separate the questions into half, and yes, it would be possible. You can actually put a Boolean array and put a filtering here, so you won't get the same combination 6 and 4 and 4 and 6 again, and you don't have to do this sorting again because you reason. And as the number goes big, the next number should be smaller. So 2 and 8, 4 and 6, then we can actually remove this comparison because we are doing from the small number and effective cut the iterations that we want to go by half. So that's it for this question. The next thing, the Playboy gym, you can figure it out yourself. Is quite challenging because you need to find the value that is uh, higher and lower than the number in the array. You need to print it out, and you need to consider the number is not found, then it should goes to the uh, correct value. So other available question, you can go to Yuhan or the question listed in the book. So the next is bisection method. So instead of having these nice notes splitting into half, bisection method is a good way to solve mathematical problems, but it's an approximation. So example, if we want to find square root of 5, we grab the previous perfect square number and the next perfect square number. So roughly we have a range. So the square root of 5, right? So if we square root of 5 should lie nicely between 2 and 3. So the next thing you want to do is to try out 2.5, which is 2 plus 3 divided by 2. So we try to get the value. Square it, and we found 6.25, so which is still larger than 5. So we can reduce our range to here. And the next thing, we can eventually do 2.25. Let me check the value. 2.5. So the value for square root 5 is 2.236. So on the next look, we found that 2.125 is actually its square is actually smaller than the value of square root 5. So we can reduce our range from here to here. And by doing on perhaps like 10 times or 50 times, then you can get the approximately good value for the value of square root of 5. So, but the issue is sometimes we might get the repeating answer due to the precision error in double. So instead of doing while we got the value, we should do a loop for 10 times or 50 times. Then we should not get the infinite loop. So the example 10341. So you are given the equations and the values for the constants. So what you need to do is to find the value of x such that it satisfy this equation. So given the range of x is 0 to 1 here. So after doing the analysis in R programming, then I found that the graph actually has two patterns. One is going up and another one is going down. So what we need to do is to ensure the starting point between 0 and 1 cut across 0. So for the graph like this is simple. We just need to check the starting point and the ending point whether they include 0 or not. If that they don't include 0, then we can safely conclude it has no solution, no value for x. Otherwise, we can perform a bisection method by separating the value into half and check which segment I should go. I should either go from 0.5 to 1 or 0.0 to 0.5 and so on. Like 50 times, then you should get the solution, which I have the solution ready here. So first we print the line, we read the line, then we set it into the double variable in order to preserve the precision, so we don't need to use integer here. And mean value and max value. If the mean value is either more than 0 and the max value is less than 0, then we should continue to perform the bisection method. So I will get the minimum and maximum divided by 2, then I test the value. If the value is less than 0, then I should go to the upper segment. Otherwise, we should go to the lower segment. Otherwise, we go to the upper segment. So the special thing about this question is opposite to the binary search method that we have discussed just now, due to the opposite graph, which is here. So if the initial minimum value is 0, then we print 0. If the initial value, the value for 1, x equals to 1 is 0, then we print out 1. Then otherwise no solution. So that's it for this question. So you have other available questions: 11881, 11935, 2.1. So for this question, you can the USSCO playlist. So here's the conclusion time. For the example we have discussed just now, we are actually solving problems in ON log base 2 because we are dividing the solutions into half each time complexity instead of ON linear search. So for the large amount of test case, the log n will have will be faster than ON solution. So which you can see from the graph here, the ON solution with the scales linearly with the data size, but for the log n solution, it scales logarithmically. So when would we use this? The first is we know that the range of the solution, the minimum and the maximum bound of this answer. So we divide the range into half every time. And the set of answer to search is either in increasing or decreasing order. But this is not so important because you can always perform your sorting for the data. So that is it for this. So that is it for this session. So for the next session, we are going to discuss about dynamic programming. So see you next week.